Notes for 12.3, cylinders and cones. It's the same thing as a prism or a pyramid, it's just that your bases are now circles. So if you look here, the radius, and then we have the altitude. Altitude is the same thing. There's not really a lateral edge here because we don't have lateral faces. Okay, now when we did lateral area for a prism, we did perimeter of the base times the height. Well, the perimeter of the circle is 2 pi r, or the circumference, and you can kind of see here that lateral area is the rectangle that wraps around the circles. So the area of that rectangle would be the height times the circumference. Honestly, I would just remember the prism formula and then use that. But if you want some more formulas, you're a big fan of memorizing formulas, here you go. Total area is still the lateral area plus the area of the two bases. And this time they are two circles, so that didn't change. And the volume is still area of the base times the height, and the area of the base now is pi r squared and then times the height. So everything's the same as it was, it's just we have circles as bases. Again, in the cylinder there are two, like a prism. And then when we go to the cone, okay, you'll see there is a right triangle here. We still have a slant height, and we still have a separate height of the cone. And then we have the radius down here. So this is the right triangle that you'll want to use. Okay, and once again, all the lateral area, total area, and volume formulas are the same as they were for pyramids. Again, you just use the circle formulas. So L is still the slant height. You can simplify it down. You can see here to pi r times the slant height. But again, if you remember this, I think you can determine that. So here we have a cylinder and a cone, and you can write those measurements down. In this, the radius is 5, and the diameter of the cone is 24. These are the heights. And so you're going to find the area of the base, that's big capital B, lateral area, total area, and volume for each of these figures. So I'm going to ask you to push pause, work through those, and then you can come back and check your answers. All right, here are the answers. For the cylinder, area of the base, pi r squared. Lateral area, this is the circumference, 2 pi radius, times the height, which was 7. So the lateral area is 70 pi centimeters squared. The total area is 2 area of the bases plus the lateral area, and the volume is the area of the base times the height. For the cone, very similar, but notice how the lateral area formula changes now. It's 1/2 perimeter of the base, which is the circumference, times the slant height, which was 13. The total area, again, I did the lateral area plus 1 base, because there's only 1 base in the cone. And then for the volume, it's not area of the base times the height, it's 1/3 the area of the base times the height, so you can work through that as well. Now, we did not originally know the height, so I used the right triangle. I drew it separately here in blue and used Pythagorean theorem to figure out that that was 5. Right, and the next one, again, we have a cylinder. Be careful, make sure you, when these are written out and not containing a picture, that you use the right formulas. So go ahead and give these a try and fill in the table. Right, here are your answers to these with work shown. So you can push pause, check your answers, check your work. If you have any questions, please let me know. Over here, I took the volume. So here's the formula of a volume. I plugged in everything I knew, so I knew the volume and the height, and I proceeded to solve that equation to find radius was 4. Okay, now we have a cone and a table, and we're going to do the same thing. So go ahead and push pause and fill in the table. All right, coming back, here are the answers with work shown. Again, in the bottom row here, here's your formula for area. I filled in what I knew. From this step to this step, I multiplied both sides by 3 to get rid of the 1/3. So that's where this number came from, and then divided both sides by 2 pi. So push pause if you need more time on those answers. All right, for these two problems, why don't you give those a try? So push pause, give them a try, and then come back. All right, for this, a cone, it's being filled, so I know I need volume. So for the volume of the cone, I found that out by Using the formula, I got the volume as 144 pi. Now the volume of the cylinder, I need that to be 144 pi. I know the radius of the cylinder's base is 4, so the area would be 16 pi. And solving that equation, the height of the cylinder would need to be 9. Down here, I have a right cone and a right cylinder. That just basically, again, means that it's not oblique. And they have equal base areas. Now, I don't know what they are. I just know they're equal. So the height of the cylinder is 4 times the height of the cone. So all I did here was plug that in. Now, I can use capital B, and I didn't need to use different ones because they have the same base area. So I set them up into a ratio. This is the cone volume. This is the cylinder's volume. I used 4H because the height was 4 times the cone, the height of the cone. I canceled the B's and canceled the H's. That got me to here. I multiplied top and bottom by 3, and we find the volume of the cylinder is 12 times that of the cone. All right, and there are practice problems in Canvas, so check those out, and that is the end of the 12-3 notes.